Hello, Hopewell. In this video, we will continue our learning with Chapter 9. This is a setup lesson before we begin Chapter 9 that will help you to be successful on the remaining videos in this chapter. We'll start up with this warm-up. The directions say simplify each expressions, and when I look at all 6 of these expressions, I don't think I can simplify anything. There's no equal factor in the top and the bottom to cancel out because these are all fractions. But what I do notice is that each denominator has a radical in it. So what we're going to need to do is rationalize some of these denominators. I may not take you through each one, but I'll just do a few of them. Like the first one, if we have the square root of 2 in the bottom, we're going to multiply the numerator and the denominator by square root of 2. When we evaluate this, we get the square root of 2 divided by 2. Since neither the top nor the bottom have a common factor, we can't cancel it, and this is as simplified as it gets. Question 2, we'll do the same thing, but instead we'll use a square root of 3 to simplify this. So we have square root of 3 divided by positive 3, and that's it. For this one on the right, we don't have to multiply by both 3 and square root 2, only the square root of 2 needs to be multiplied to the top and the bottom. To rationalize the denominator, the 3 is rational, the square root of 2 is not. So we have 4 root 2 divided by 3 times 2, which would be 6. This would be simplified except the outside factors, your whole number factors, your rational factors. 4 over 6 can be simplified to 2 over 3. So 2 root 2 over 3. Bottom row, we have a square root of 3, square root of 20, and square root of 12. 3 is prime. We'll just multiply by square root of 3 times itself. So we get negative 3 root 3 divided by the square root of 3 squared is 3. These 3's are going to cancel. So what we have left is negative square root of 3 is our final answer. Over here, I'm not going to multiply top and bottom by square root of 20. When I said that this was prime but these are not prime, what I want to do is maybe simplify and factor this first. The square root of 20 has a perfect square of 4 that can divide it. So the square root of 20 is the equivalent of the square root of 4 times the square root of 5, or 2 root 5. Now that I've simplified it just by factoring the square root of 20 and simplifying it, I'm going to multiply the top and the bottom by square root of 5. Lo and behold, we have negative 5 root 5 divided by 2 times 5, or 10. The outside factor of 5 and 10, these will reduce. Negative square root of 5 over 2. This is your final answer. Our last one, same thing, the square root of 12 is composite. We can simplify that. 4 times 3 makes 12, so square root of 4 times square root of 3 makes 12, so 2 root 3 is the denominator after you simplify that radical. What should we multiply the top and bottom by? Let's multiply top and bottom by the square root of 3. Distribute your top. We'll get 3 root 3 minus square root of 15 divided by 2 times the square root of 3 squared, or 2 times 3 is 6. This is okay. I always like to instruct you to divide both of these terms in the top by the 6, because the 6 is dividing both the 3 root 3 and the 15, the square root of 15. So this would be square root of 3 over 2 minus the square root of 15 over 6. This to me is a little bit more simplified. So that's our warm-up. Underneath we have another section, but if you have any questions, come back to this video, maybe watch it again, or you can send me an email. Our second section says label each side of the triangle. We're going to write O for opposite, A for adjacent, and H for hypotenuse. Now each of these 6 pictures are right triangles, and they are marked with this 90-degree angle in the corners. These other angles are something that we will refer to as a reference angle. It's the angle of reference, which will determine where your placement is. It's like if you're standing here, what side is opposite, what side is the hypotenuse, and what side is adjacent. I do want to go back over the word adjacent, which means next to. Now there are, looks like, 2 sides that are next to this angle. However, one of them is across from your 90-degree angle, which makes this your hypotenuse. The hypotenuse is usually the easiest one to identify. Opposite is a little bit tougher. If you walk through your triangle from your angle, from this vertex angle, and you walk through it to a side that's opposited, this would be the O. This is your opposite side. What side is next to it? Adjacent. I might go through another one or two of these examples and explain it a little differently. Let's see what I can do here. Here's your 90-degree angle for number 2. Across from your 90-degree angle is your hypotenuse. The other two sides are what we refer to as legs. You might remember that, but the legs have different terminology to them because of this reference angle. One of the legs is opposite and the other is adjacent. Opposite to this reference angle. So I said if you walk through standing from this vertex, we'll get there. Well, the opposite side is not either of the sides that make up this angle. This side and that side make up the angle. So the opposite side is the one that does not make up that angle. And then here you have the adjacent side. This pretty much is what I wanted you to accomplish in this section. Just mark opposites, adjacents, and hypotenuses. These vocabulary terms are very helpful for us in our chapter. I'm going to pause it right here and switch the page. This back page that automatically just appeared is the reason we need to identify sides as opposite and adjacent and hypotenuse in right triangles. This chapter deals with a lot of right triangle terms and what we do with our right triangles. You might have already learned the sine and cosine and tangent for a given angle. By the way, I don't know if you recognize this symbol, but this is the symbol that represents a marked angle. This is a Greek letter. The Greek letter is theta. It makes a TH sound. These three, sine, cosine, and tangent, you can find the ratios of sine, cosine, and tangent if you're given an angle like theta. So if this is the marked angle, the opposite side and the adjacent side, you can begin to determine which side is what, and your hypotenuse is always the longest side and across from your 90-degree angle. Sine, cosine, and tangent are the ones you learned. These three are the reciprocals of sine, cosine, and tangent. These are the abbreviations for cosecant, secant, and cotangent. I'll write those out. So instead of they're not inverses, they're not opposites, they're called the reciprocals. The sine is the ratio of your opposite divided by your hypotenuse sides. This is the hypotenuse divided by the opposite side of your angle. So that's how these work, and these are what we're going to refer to later. This is going to be also covered in our next video. The last section at the bottom deals with two special right triangles. Special right triangles have 30, 60, 90-degree angles or 45, 45, 90-degree angles. From geometry, you might have learned that they have a special pattern to these. Like if this side across from your 30 degrees is a length x, the hypotenuse will be double that side, would be 2x. This down here, this side will be the square root of 3 times bigger than the value of x. Let me just focus that in again. So your small leg is x. Your hypotenuse is double the small leg. The middle leg, or the middle side length, or the larger leg, I should say, is the square root of 3 times bigger than the small leg. Alright, let's take a look at the 45, 45, 90-degree right triangle. This leg is x, and because it's opposite of 45 degree, then we have an isosceles right triangle, so the other length of the leg is the same, x and x. The hypotenuse is the square root of 2 times larger than each of these 45-degree legs. And so why do I need to teach you this? We need to then go into something called a unit circle and a unit right triangle. This unit right triangle has a hypotenuse of 1. What we can do to convert these to those is to divide each of these triangles by a hypotenuse. Here we're going to divide each side length by 2x, because 2x divided by itself will give us a 1. So let's label these sides. If I divide x divided by 2x, I get 1/2. X divided by 2x, I get 1/2. Why am I dividing by 2x? Well, if I divide by 2x, then my hypotenuse will become a 1. So I'm going to really take a look at all these and divide them by 2x. Now this side length is 1/2, which makes sense because if x is 1/2 of 2x, then 1/2 is 1/2 of 1. Next, we're going to cancel out these, and we're going to get the square root of 3 over 2. So what we're going to do is, again, convert this triangle to that one where the hypotenuse is 1. What we need to do is divide the hypotenuse by itself to make it a 1. So divide all 3 of these sides by the square root of 2 times x, and reduce. The square root of 2 divided by itself, and x divided by itself is 1. X goes into x goes into x once, and x goes into itself one time again. So this becomes 1 over root 2. Think back to your warm-up. Can I label a side with 1 over root 2? No. That side length is not rational. That denominator, I should say, is not rational. Rationalize the denominator, multiply by square root of 2 over square root of 2. And there we have our leg length for each of these legs. Why are they both the same again? Because they're both opposite from 45-degree angles. This is our preview video for Chapter 9. Please move on to Section 9.1.